Here you go. All right, so counterpart to yesterday's lesson, we looked at summation with arithmetic sequences series, and now we have to do the same thing with geometric. So yesterday arithmetic, today geometric. So same idea. Geometric series is the sum of the terms of a geometric sequence. So if in words they said a series, then you should be thinking sum. But again, usually the notation, you'll see the capital S or you'll see the sigma notation. One of those two will be there, and so it just depends upon the situation. One of those two formats are going to be there. All right, so same idea, right? Summing up the series all the way through whatever. All right, so what's the complete formula? The first one, the only thing you need to add to this thing is a sub 1. So the first one has the first term times 1 minus r to the n divided by 1 minus r. That's going to allow you to sum up a geometric sequence. The second one is a sub 1 minus a sub n. And if somebody will grab your book and turn to 12.5, I just want to make sure that this is correct. I've got an r after that. I just want to make sure there's no parentheses there and I wrote it down correctly. So first term minus the last term times r divided by 1 minus r. Okay, no parentheses, right? Yeah, it just looks odd, but all right, so two different ways, two different situations, and it depends upon which one you're going to use. In both cases, you need the first term. The first case, you don't need the last. In the second case, you need the last. First one, you got to play with the exponent. Second one, you don't have to. So either formula, first one if you don't know the last term. Second one's easier if you know the last term, but again, you got to remember them, and that's probably the harder thing. Okay, so let's find the sum of the first 10 terms, right? That's what that's saying. S sub 10 says sum up the first 10 terms for the geometric sequence 3, 15, 75, etc. All right, so what's the first term? Hopefully everybody says it is 3. All right, what's R? 5, right? Because you take any term and divide it by the previous term, and 15 divided by 3 is 5, and by the way, 75 divided by 15 is 5, right? It's got to be that case, common ratio all the way through, and then n, of course, is 10 on this thing. And so, all right, on this one, you don't know the 10th term, so therefore I would use the first formula, right? So go ahead and run it. I'll do it up here while you guys do it there. If you need to look up, feel free to look up. But you're just running your numbers. So we're summing up the first 10 terms. And remember, geometric, this thing's going up exponentially. So your number should be fairly large. And you got to make sure you can punch this correctly. So you guys really need to get your calculators out. And you really need to punch this in, everybody for themselves. So I got what, 7,324,218? 7,324,218. Again, just make sure you can punch it into your calculator. So we need a sub 1, we need the first term, we need r, and n they're going to tell you because they're telling you to sum the first 10 terms. Okay, any questions on that? So that's kind of the idea, and that's what you're going to need to reproduce each time. So the second situation, similar. S sub 20. You can see this one, though, goes 12, 6, 3, so we're getting smaller and smaller as we go along. And so now we got to add all that up. This thing converges, by the way. We'll talk about that toward the end of the lesson. So go ahead and do that one. Again, I set it up a little for you. Put a sub 1 there, r there, and n there. And then you can do the exact same thing. If you need to look up here, feel free. But try to do it on your own. My answer makes sense. And this thing is what, 23.99998? I wrote a bunch out. 23.99998. I just didn't want to round that one off. Maybe you put 24.0, but that's fine. Oh, I did say hundredth, didn't I? So tenths, hundredth. I didn't even read my own directions. 24.00, right? The nearest hundredth. Always read your directions. So we're converging. And again, we're at 12 and 6, 18, and 3 more, 21, and 1.5, that's 22.5. And as you add up all the little dribbles through to the 20th term, you're going to end up rounding off to 24. Okay. Questions on that one? Anybody? Okay, so summation symbol, right? Sigma notation. And we're basically doing the same thing. There's not a whole lot of difference here, as if they would have said S sub 7, right? For the series where 3 equals K. So go ahead and see if you can do C. More than 1,000 or less than 1,000? 2,000. 3,000. 4,000? All right, so sounds like you're in my ballpark. 3,279? 3,279? You might say, I didn't know what R was. Okay, so that goes back to something we learned earlier when we did geometric sequences, right? That the R value is the base. And so R was 3 in this one. You say, does the first term always match the R? No, it just so happens in this sequence it did. But the first term doesn't always have to match the R. You can see the previous one, that was not the case. All right, but in this one, so again, where did R come from? It was the base of that. So A sub 1, put in 1 for K. N was 7. Now you got everything you need. And away you go. How many got that one correct? Okay. So you're just trying to put into practice what we did. All right, so what are you going to do with something like this? Find A sub 4 for a geometric sequence where R is 2 and S sub 6 is negative 315. So I told you to first find A sub 1. If you find A sub 1, then hopefully you can go from there and figure it out. So how are we going to get A sub 1? What are we going to do to get A sub 1 out of this? A sub 1. Ideas. Leah, is that a handout?
Oh, sure. Use the formula and then
Which formula?
the first.
Okay, so two formulas. We know S of n, we know R, and we know n. Agreed? Therefore, it leaves one variable, a sub 1. Okay, so that's what we need to do. So go ahead and run that first formula and get a sub 1. And again, if you're not sure what to do, I'll put it up here. If you think you know what to do, go ahead and try to do that on your own. All right, so you should have gotten there. Hey, what I would just do in this case, I would just take care of that negative 1, make that a positive. So we're going to end up dividing 315 by negative 63, and did we get negative 5? Okay. So again, you're just running the formula. Pretty straightforward on that, just algebra. Okay, so how are we going to find this fourth term now? Luke? Let's see. We know a sub 1. Use the second formula to try to accomplish getting a sub n? Yeah, because I would use the explicit or general term formula. That's the better way to go at this point. So you got to remember, what is it for a geometric sequence? And again, that's the thing you got to be careful here in this chapter. We keep looking at arithmetic sequences and then geometric, right? Arithmetic and then geometric. And you have to keep straight the two. So you got to remember, okay, what is that explicit formula or general term formula for a geometric, right? It's a sub n equals a sub 1 times r to the n minus 1. So with that, you can go ahead and figure out a sub 4, right? Because we know a sub 1, we just found it. We know r, and we know what n's going to be. So you just finish it up subbing in, right? So go ahead and sub in and finish that thing up. You can even do that one in your head. Don't even need your calculator, right? So hopefully you all know 2 cubed is 8. And 8 times negative 5 is a negative 40. Right, in the fourth term. So in that situation, we're able to use our formula to get the first term. If you know the first term in R, you can get any term from the explicit formula. So that was the thought process. 2 steps there involved. So if you had that problem cold, you got to say to yourself, how am I going to get the fourth term? Your thought should be, the explicit formula gets me any term. So really, if you were doing this one cold, your first thought should have been, I need the explicit formula, and you should have written that first. And then you should have said, but I don't know a sub 1. Therefore, I'm going to do this to get a sub 1. That would be the logical progression. I need the explicit formula to get any given term. Okay, write the explicit formula. Oh, I need the first term because of the explicit formula. Therefore, let me use the summation formula to get the first term. Now I have what I need, and I can find the fourth, right? That's the thought process. That's the progression you have to go through. Any questions on that? Okay. All right. Number 4. Number 4. An infinite geometric series can be classified in two ways. An infinite geometric series can be classified in two ways. All right, one, it converges. So, vocabulary word, are you familiar with the word converge? Right? If things are converging, they are heading together. Every time the bell rings, students converge in the hallway. And sometimes it's really converge, right? Coming together. That's the idea, and so converge. All right. It converges if this situation, whoops, that looked like a D and that's supposed to look like an A. If the first term divided by 1 minus R. So here again, we need a first term, and we need the value of R, the common ratio. And so if the sum equals a sub 1 over 1 minus R, if the absolute value of R is less than 1. So to sum it up, you do a sub 1 over 1 minus R, and it converges if this scenario. Okay? Maybe I should do the arrow the other way. So converges means R is less than or equal to, or is less than 1. And how would you get the sum? Just do the first term divided by 1 minus R. Pretty simplistic. You might want to think of this as heads toward a limit. Heads toward a limit. Those of you that will take calculus as seniors, some of you will, I'm sure, in this class. You'll take calculus as seniors. You'll talk about the limit quite a bit. And I from pre-algebra, tried to start to condition you to understand that division by 0 is infinity. And what happens in calculus, we'll learn to take things to the limit. And by taking them to the limit, we'll actually find values of things that seemingly are unsolvable. But that's calculus. All right. Anyhow. If it converges, it heads to a limit. The other possibility is if it doesn't converge, then it diverges, right? So diverges. And if converge is an R less than 1, diverge has to be absolute value of R that is greater than or equal to 1, right? We don't want to leave 1 out there. 1 is kind of boring. What would be the series of an R equal 1? It would be like 7, 7, 7, 7, 7, 7, 7, 7, 7. But if you're doing a sum, right? If you're doing a series, you're gonna keep adding 7 plus 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 7, often to infinity, right? So even an R of 1 is still gonna have a diverging value. So diverges, instead of heading toward a limit, a value that's converged, it heads towards positive or negative infinity. So heads toward plus minus infinity. So converges or diverges. So let's do a few of these. All right, so see, for each geometric series, determine if it converges or diverges. If it converges, find the sum. Again, if it converges, how do you find the sum? First term divided by 1 minus R. Pretty simplistic. First term divided by 1 minus R. All right, so we need R. So you look at that first one, and you have to determine R, because it's all about the absolute value of R, right? So you look at that and you say, oh, R is 3. So this thing diverges, right? It's an ugly implies symbol. So number 1 diverges. So, and this one is heading toward positive infinity, negative infinity. Negative infinity. Guess what the sum of that sequence is? Negative infinity. Okay? You say it'll be bigger than negative infinity because it even includes negative infinity. All right, we'll play around with that in your mind for a while, and maybe you can come up with something Einsteinian and be famous. All right. But, you know, again, you're summing up all the numbers all the way up until negative infinity and including negative infinity, so it's a pretty big number. All right. Or a pretty negative number. It's off to negative infinity and not beyond. All right, so the second one, again, you're after R. And it shouldn't take you long to understand that R is a half. So go ahead and sum that sequence. Go ahead and sum this converging sequence. Come on, Windows, cut it out. It's going to keep doing it today. And so, where do we end up here? 240? What are we saying on this? So I just want to pause for a second. Everybody okay with the 240, right? I mean, it's just pretty simplistic. 120 divided by 0.5. You can use a half if you want to knock yourself out with fractions. Think about what we've got here. We've got 120 plus 60 is 180, plus 30 is 210, plus 15 is 225, plus 7.5 is 232.5, and then my brain doesn't want to do them anymore. 232.5, and at that point we're at 7.5. Then the next one's half of 7.5, right? 3 point whatever. Then the next one's half of 3 point whatever, 1 point whatever. Then the next one's half of 1 point whatever, point whatever. And then the next one's half of that, point whatever. And the next one's half of that, point whatever. And the next one's half of that, point whatever. And point whatever, and point whatever, and point whatever, and point whatever. And guess what? When you add up the next one, and 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 the next one, forever and ever, what do you get? 240. Okay, that's what we're saying. I say, no, can't be. I mean, all those forever pieces, we got to get bigger than 240. No, it's 240. That's what it is. Adding them up, forever and ever, without the amen, 240. Okay, that's what we're saying. And you can play with it if you want. You can play with the numbers and take a look. But that's where you're going to end up. Because what happens is you just keep adding smidgen and smidgen and smidgen and smidgen. Because a half of 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 a half, you just keep getting smaller, 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 smaller. And so it's adding just very, very little. Final value, 240. All right, so what about the next one? What about the next one? Same R value, right? So again, this thing's going to converge. And so off you go again. Go ahead and figure out what some would say the limit on this. Or actually the summation. The limit is the value it's heading toward. But anyhow. All right. And this thing you end up at, this one you end up at, negative 24, right? So summing those up. And again, you're at negative 18, negative 21, another 1.5, negative 22.5, and then another, point whatever, and point, and you end up at negative 24. All right, those are not hard to do. So what happens when you come across something like number 4 and you just come across it all by itself? Okay, notice the last value here of the term. We want an infinite amount of terms, right? And that is supposed to look like infinity. So we're off to infinity. So you could sum it if it's what kind of series? If it does what? Right? You can sum it if it converges. If it diverges, you can't. So all you're simply going to do first off is say, does this thing converge or diverge? And your answer is it diverges. Some may say, how in the world did you figure that out? Remember, this is R right here. 1.02. And therefore, it diverges, and there's not going to be a solution to that. Because guess what? It goes on to infinity. You can put infinity if you want. And if you want, you can put positive infinity if you want to put an answer down. But infinity doesn't calculate too great. However, the second one you can do. So go ahead and figure the second one out. Because hopefully already you say, oh, I get it now. That one converges. So now go ahead and sum all the terms of that geometric series. Oh no, I need a sub 1. Whoa, brain said 1. Hand wrote 1. And what are we? 1 minus R. So what do you end up with? 3/5 divided by 2/5? Right? 3/5 divided by 2/5, and the answer is? What is it?
3/2.
Huh? What? You're okay. Hold on. My brain isn't following you. 3/5 divided by 2/5, right? Oh, you said, okay. When you guys said 3/2, I'm like, well, no, 3/5. All right. Yes, 3/2. The brain is doing strange things today. Who knows? All right. 3/5 divided by 3 by 2/5. And so again, you're just punching your calculator. If you punch it, your calculator might have said 1.5 because that would be 3/2. But a 3/5 divided by 2/5 is a 3/2. All right, whatever. Let me do a couple things here before we're done. Just want to show you a couple things in this section. So, situation here. Golfer wants to hire you to caddy and offers you a choice of payments. He'll pay you $1 for the first hole, 2 for the second, 3 for the third, and finally 18 for the 18th hole. Or you can choose to be paid 1 cent for the first hole, 2 cents for the second, 4 cents for the third, 8 cents for the next, and so on to the 18th hole. What would be the total pay in each of these systems? Well, the first system is an arithmetic sequence, right? Because you're going $1 and then $2, so the D value is, right? You're figuring out the D value and you're going all the way, and so we're summing up the first 18. So arithmetic sequence in the first case, so $1 plus $2 plus $3 plus $4 plus $5, D value of 1, and you're going all the way through, and your pay would have been $171. Not bad. You wouldn't mind caddying for that. Caddies and real estate agents. I mean, you just got to be in the right place at the right time, right? Like, what if you're caddying for Jordan Spieth? Isn't it like you get a percent of what he wins? You know, what if you're a real estate agent and you're in Cleveland, Ohio, selling a $60,000 house, or you're in Woodbridge, Virginia, selling a $100 million, no, $100 million, $1 million house? Same percentage. So what do you think the penny thing's going to give you? Yeah, it's $2,621.73. So quite a bit of difference there in going the 1 penny, because that second sequence is a geometric sequence because you are doubling it each time value of 2, and when you run the numbers on that, you get $2,621. What was the thing with the cent doubling, doing the geometric every day for a month? I think you're really up there on that one if you do it all the way through. You could play with it, just do S sub 30 or S sub 31 if you want to, and you can figure out what a penny would be doubling every day for a month. It's a good amount of money, right? You can sum it up, just takes a second. You're just changing the 18 to a 30 or 31. Anybody calculating it as we speak? All right, so when you get there, let me know. How much, Alex?
10,700,000.
All right, 10,700,000 plus. Nice, right? You would never think, would you? A penny doubling every day for a month. 10 mil. Okay, because it's going up. It's exponential, and it's going up. All right, you guys, you've heard of annuities, right? You've never heard the word annuity? All right, your parents have, okay, because you're young, and this is an old people's thing. An annuity is a sequence of equal investments made at regular intervals. Suppose that at the end of every month until retirement, age 70, a 20-year-old sets aside $50 into account paying 6% APR. Compound it monthly, so that's 0.5% per month, right? Because 6% a year divided by 12 is 0.5% every month. At retirement, he would have made 50 times 12 or 600 monthly payments, right? So from age 20 to 70, he would have made 600 payments. You can make a sequence out of this thing, and by making a sequence out of this thing, you could figure out then the sum of the value of these 600 months. And that's the idea, and that's the concept here. And so you just run in the formula, right? Does that look familiar? It does. There's a summation formula for a geometric sequence. And when you sub in the 600 and the 50 for a sub 1, the 1.0005, 0.5%, right, is 0.005. So your R value 1.005, N is 600, $189,359.55. That's not bad. That's not a bad amount. And look, here's the thing. The person would have only paid $30,000. All the rest is interest. And so $159,000 is interest. The miracle of compounding, that is the idea. The book does give you, I keep changing it, sorry about that. The book does give you some annuity formulas there. This is in your text. One other thought here. A ball is thrown 50 feet in the air and rebounds to 80% of its previous height on each bounce. You guys get the idea, right? Ball's thrown in the air, and it goes 80% each time. 80%, 80%, 80%, 80%, 80%. Not on carpet, because it wouldn't go 80% on carpet. Maybe concrete, something nice, and it's a nice bouncy ball, right? Super Ball would probably go 80%. All right, well, you can model this thing as a sequence. And so, you got 50, then 50 times 0.8, right? 80%. Then 50 times 0.8 squared, then 50 times 0.8 cubed, and on and on and on you go until finally you could figure out that this thing is 500 feet. Why double? Because the ball travels up and down each time, right? Up and down, up and down, up and down. Double the whole distance, 500 feet. I thought that was an interesting problem. All right, it's Wednesday, so I'm not going to assign homework. I will quiz you over some of this tomorrow. So if you want to work some odds on your own, I would do that. I would definitely look over my notes. Quiz tomorrow.